Howdy, welcome to Knife Making Tuesday. I'm your host, John Grimsmo, and this week we're going to work on facing titanium. So I've got a stack of Norseman handles here that happen to be too thick. Normally I get them double disc ground, so they look like this. From 156 down to 125, double disking makes them perfectly flat and parallel and awesome. But I had them do a batch not double disked, so we can play with thicker patterns and stuff, but to make my life much easier, I'm just going to face them down and deal with thinner handles. So to face them down, there's a lot of ways you can do it, but I'm going to focus on these tools from Tormach. They're from their modular insert line, and I've used them a little bit, but I haven't used them enough, and I want to play with them. So I've got two of these because I completely crashed this one a while ago, if you can see right there. I don't even remember what I crashed it on, but it destroyed itself. So that was fun. So I got another one. This one's brand new. These are in some ways better than endmills because when an endmill wears out, you have to replace the whole thing. That's a lot of carbide to buy. When an insert wears out, especially these round ones, you just rotate it. And you get many rotations, depending on how much of it you're actually using. You get many rotations per insert. And an insert's like $8 to $10, whereas a carbide end mill this size is 20 or 30, I can't remember. So although this is $30 in inserts, you get a lot of rotations out of it. Very long tool life, very cheap tool life. So that's good. I've got two styles here, a square cut and a round toroid cutter with 3 inserts versus 2. These are both about 0.98 inch diameter cutting diameter. To face down the handles, I've already been playing with this some, and I've got two that we did. One is with the flat cut, the square cut, and then that's with the toroid end mill. Can you see it good enough?
Yeah. Try to show me more with things. You're kind of looking at them yourself. That's better.
Yeah, so we're playing with tool paths and strategies and finishing, more importantly, speeds and feeds. Because it's kind of a big, heavy cut to do a 1-inch diameter cutter to plow through about 30 thousandths of titanium. Titanium's very fickle with speed and horsepower and stuff. And I'm getting a lot of chipping and wear on the inserts because I think I'm pushing it way too hard. So let's see it. So here I've got 2 pairs of handles mounted on my fixture. We're going to machine them one at a time. So the first one, I'm going to use this square cut end mill. And I'm going to use my older speeds and feeds, which are quite aggressive and they cause edge chipping, but it's pretty fast and it looks cool and it makes a lot of sound and vibration, so it's going to look cool. And then on the second side, we're going to do the same thing with the round insert end mill. And then for down here, we're going to slow it down a lot, which I haven't tried yet, and see how that looks. Hopefully it's going to lead to longer tool life and a better surface finish, but it's going to take longer. So let's go. Vacuum on. Let's see, tool 59. You can even film like me doing this stuff.
Yeah, I think we're going to have to rely on the GoPro for in there.
Yeah.
Can't see through the screen.
Yeah, okay. Tool 59. All my offsets are good. If you can see this, this is my tool path using HSM Works. This is a adaptive machining tool path. This is at 1800 RPM and 50 inches per minute, which is flying for me. Safety first. So into the cut, it's going to helically interpolate down. And here it goes. Starts a little high just for clearance. Should be cutting now. could probably open this. Yeah, not get too.
Oh, yeah.
So that's cutting pretty hard there. So this is removing, it's actually shaking the floor a little bit. This is removing about 0.35 inches per minute of material and taking about 0.35 horsepower to cut, which for this machine is a decent amount, in titanium no less. The surface feet per minute is like 450, which is probably way higher than it should be. And then right now it's going in for a finish pass. A little bit higher RPM, 3600 RPM, and a slower feed rate of, I think, 16? Yeah. All right, how'd that look? Yep, same as before, maybe a little bit better actually. Yeah, you can see here the inserts. You zoom in on these. This top corner right there. These were brand new. You can see this bottom corner where I did it the last time. Yeah, it toasted them. It's too hard, too fast. So for these round inserts, actually, I've got the smaller version from Tormach. This is about 0.63 diameter. And we use these to machine the bevels on our blades. So this is a tool we use to buzz all this contour. So we use this a lot. And I got pretty good at using a paint marker to mark the dull section. So basically from just past 90 degrees, just a little bit past, and then however deep your cut is. I do that, and that way when I rotate it, I can see the paint. Usually it stays on pretty good throughout the cut, so I can see the dull part. Otherwise, you just kind of look at the edge and see where you can see daylight shining back at you. And using a loop or whatever makes it pretty easy to see that. So I'm not going to bother with the paint marker right now. Just going to loosen it, rotate it, just guesstimate how deep I need to go. Do that for all three. So now I'm going to come over to the mill, turn the GoPro back on. Recording GoPro. So basically on this other handle, I'm going to do the exact same type of code, the same speeds and feeds and everything. The only difference is we're using the round insert end mill as opposed to the square insert end mill. And you can really hear the difference and see the difference in the chip. Because these are the chips that came off with the square insert. Very long and stringy. And they're nice looking chips, I guess. But the ones coming off of the round insert are much more scalloped. They look really cool. So we'll put this over here to save it and we can compare. Vacuum on. Open up different code. Display, that's the one. Change to tool 23 and go. Hopefully I did this right. GoPro should be recording. hand on the E-stop just in case. Oh, sounds good. So just the way these round inserts kind of scoop away the material, it's a lot more gentle of a cut. Watching it, it looks smoother. It's still an aggressive cut. It's the same metal removal rate as the other tool. It's just quieter, there's less vibration. It's wonderful. But these speeds and feeds still wear out, they wear out the tool. So the toroid one just finished with those faster speeds and feeds. Let's come look at these chip oleos. There's some smaller ones from the finishing pass, but these bigger ones, they're just bigger and longer and thicker and swoopier because it's just taking a better cut. So I think overall I like using the toroid a lot better when you can. Spray this off now. But as for the finish, the square end mill looks like it's leaving a better finish. Yeah, if you're looking real close there, you can see the one on the right has a lot of swoopy, deep, swirly lines. And I think the reason for that is the 3 inserts on the toroid of the Tormach cutter are not at the exact same height. I was measuring a couple of them, and they can be up to a few thousandths off from each other in height. And that's not going to leave a super awesome floor finish. Hence why we're getting those swirly marks. Whereas the other one has only 2 inserts, and maybe they're more aligned a bit better. I'm not sure. I can't remember if I measured that. But anyway, let's move down to these next ones, and we'll just use... I'll check these inserts. Oh yeah, worn out. Same thing as before. So I'm going to flip these and then try it again with slower feeds and speeds. I find when I'm flipping inserts like this, especially the round ones, it's always good to have a technique where you always rotate the same direction so that at least you have consistency and you always know kind of which way you go. I tend to go counterclockwise. Don't know why, I just do. All right, there's all 3. Still recording. Lock side, toroid slower. That's not the lock side. I labeled them wrong, but that's okay. Yeah, this is a much slower RPM, only 980 instead of 1800. So it's half the RPM, half the feed rate. We'll see if it has enough power to do this. I've got it on the high-speed pulley on the mill, so it might not have enough torque. I don't know. We'll see. Should be cutting. I don't hear anything. Oh, I'm cutting on the same one again. Durr. I'm still cutting on the upper handle. I need to move it all down. Okay. Still recording? Yep. Okay. I've got to move this whole code down. How far? I think it's 1.65. Give me a second. .625 inches. Okay, so I got to move the whole thing down 1.625. So I'll go change code. Anywhere, enter G52, Y negative 1.625, And then at the end of the code, I'll do G52Y0 to cancel that. And it's always a good habit to just go X0, Y0, Z0. Make sure everything's zeroed. And that should do it. I think. Well, I think that works. Let's find out, shall we? Yeah. It's working. Okay, here we go. Should be cutting about now. Got my hand on the E-stop. You can tell, you can hear it, it's a lot slower. But it's not taking a lot of power. I'm watching the load meter right now. It's taking less power than the other cut, which is a good thing. So I've reduced the surface feet per minute, the SFM, by about half. I think it's at around 250 right now, as opposed to 450 or 490. The material removal rate's about half. Horsepower's about half. Yeah, right now it's at 980 and 22 inches per minute. So it's going to take twice as long as well. But with titanium, you can't rush it. Or else you just burn up tools. So the good news is basically no insert wear from doing that. So I lowered the SFM from like 470 or whatever down to 250, which made a huge difference on insert life. I was looking at it with the loop and there's basically no wear, no discoloration or anything, and I just did the exact same cut that was wearing out inserts, just half the speed, slower. So there is something definitely to that whole surface feet per minute thingy. So I got to keep that in mind for the future. So that's good. That's a setting that I like. It took almost 6 minutes to do that, to rough it and finish it, which is a little while, but whatever. Runs by itself, and if it's not really killing tools, then I could do quite a few of them without worrying about it. So I'm looking at this big stack of handles here and going, I don't really think I want to face them all down like that, because it's a lot of time and tool wear and everything. It might be easier and more fun just to modify my existing codes to use the thicker handles, which is not that big of a deal, but some of my tools I have to change to a different strategy and a different type of tool, because when I cut out the lock bar slot, the end mill I use for that is not long enough for a thicker handle. So I have to use a longer end mill, go a little bit slower, blah, blah, blah. Otherwise, in the showdown between these two end mills, the round guy wins. Especially if you're trying to remove a lot of metal. I think this has a higher metal removal rate because of the rounded corners, and it sounds better and it's much easier on the machine. However, if you need square corners, obviously you got to use the square guy. But what you could do is you could rough it out with this and then finish it with an end mill to get your flat profile, whatever you want. So it's just a choice between what you want to do. And the good thing with these is that Tormach also sells inserts for steel and other metals, and then shiny ones, polished ones for aluminum. These polished ones also work very well for titanium, but not for taking this much titanium off, I don't think. Just because they're that much sharper, they tend to wear easier. And when I'm being this aggressive with it, I don't want to wear them out too easily and chip the edges and all that stuff. But if you're hogging out aluminum, good stuff, shiny inserts. So I think that wraps up what I wanted to talk about with these two tools. And of course, the other thing I talked about with the round inserts is you can rotate them. You get a lot more tool life. With these rectangle ones, even though they're a rectangle, trapezoid something, you only actually get 2 cutting edges from them because you rotate it from this position 90 degrees and then put it in the other position. See how they're different? One's horizontal, one's vertical. So you only actually get 2 cutting edges per insert instead of 4, which kind of sucks. But again, this one can center cut. So see how this insert goes all the way past center line? So I'm pretty sure you can plunge this guy straight down if you need to and if you have the power. Whereas with the round insert you can't, but you can easily helically go down like I was doing and no problem. So round one wins in the right application. Yep, that wraps up this Knife Making Tuesday. Je suis désolé. I hope that was informational and a little bit fun to watch, and hopefully that GoPro footage worked out good. I don't know if you could tell, but I've got a new lapel mic, so maybe the audio pickup was a little bit better. Comment in the comments if you thought it sounded better and less background noise and all that stuff. So I've got the lapel mic going to a Zoom H1. Apparently this is what all the cool kids on YouTube are using. About $100 for this guy, like $25 for the mic, and we'll see how it works out. I haven't even listened to any footage from it yet. So hopefully it'll be less machine noise, less background noise, less air compressor and heater noise, and more my beautiful voice noise. Okay, thus endeth the ramble. Bye.